Lewis dot structures, and using Lewis dot structures to make molecules, larger molecules. So a Lewis dot structure is pretty straightforward if you know the periodic table and the number of valence electrons. So for example, group 1 elements have 1 valence electron, group 2, 2 valence electrons, then we jump across group 3, 3 valence electrons, 4, 5, 6, 7, 8. And a Lewis dot structure just represents those valence electrons. So for example, hydrogen is 1 valence electron, it's 1 dot. Carbon is 4 valence electrons, we'll have 4 dots. Sulfur, so group 6, has 6 dots. Now you might ask, why are these arrangements the way that they are? In other words, why didn't I put 2 electrons here and 2 electrons here? Or why did I not put this electron on this side? Well, the group, we get into how you calculate formal charges. This unpaired electrons hint at how many bonds in a molecular compound each compound can form. So for example, hydrogen can form 1 bond, it has 1 unpaired electron. Carbon has 4 unpaired electrons, can form 4 bonds. Sulfur, 2 unpaired electrons, can form 2 bonds. That is for a neutral compound, okay, meaning that there is no formal charge of 0. So it does matter how these dots are laid out. One last example, if we looked at something, bromine, it's group 7. Bromine, not boron. It has 7 valence electrons, 1 unpaired electron, and bromine, for it to be neutral, that is to have a formal charge of 0, it can form 1 bond only. That's an introduction to Lewis dot structures for the elements. So, how do you write Lewis structures for molecules? Well, it's a process. So step 1, is count your valence electrons. So nitrogen trifluoride, NF3. If you look at your periodic table, nitrogen has 5 valence electrons, and fluorine has 7 valence electrons. There are 3 of them. Do that math, that is 26 valence electrons. So your Lewis structure has to have 26 valence electrons. Step 2 is generally your least electronegative atom is central, meaning the other atoms are bonded to it. Now in this instance, fluorine, if you look at the previous slide, forms one bond normally for it to be neutral. But if you didn't know that, nitrogen, if you remember your electronegativity trends, nitrogen is less electronegative than fluorine. And you draw a single bond from the central atom to the other atoms. The next step is complete each atom's octet. Start with the more electronegative atoms. So doing that, 1, 2, 3, 4, 5, 6 around fluorine. And what I mean by an octet, fluorine has 2 electrons, 4 electrons, 6 electrons, 8 electrons around it. A chemical bond is composed of 2 electrons in a molecular compound. So 2, 4, 6, 8. 2, 4, 6, the bond makes 8. Then the nitrogen, we come in and fill. 2, 4, 6, 8. Every atom has an octet around it. Step 4. Recount the valence electrons. There has to be 26 valence electrons in this structure. And we count them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So our structure matches the valence electrons that we have. Okay, so we have to have 26. Our structure has 26. And then in a more advanced molecule, we'll look at what do you do with charges. We'll introduce formal charge for a ion a little further in the plate positive.